All right. How does it feel like it's going so far for you? You feel like you're getting this stuff?
Yeah.
I guess my question really is, am I going too fast, too slow, or just the right spot?
I would say just like keep doing what you're doing because I get it.
Okay. When is it that you are going to have to take this test? It's after school starts, right?
Well, actually, I just found out that my schedule is posted that I'm in geometry. So,
Oh, okay.
yeah,
Okay. So you're okay. Fantastic.
yeah.
It's still going to be worth you understanding algebra because you go algebra 1, geometry, and then algebra 2. And there's really not a lot of difference between algebra 1 and algebra 2. It's all algebra. So you're going to have to learn algebra to go any higher, including geometry. There's quite a bit of algebra you have to apply, even in geometry. It's probably not as complicated as the stuff that we're covering now, but all right. So we've spent a couple of sessions working on factoring. Let's figure out why factoring is so important. That's the expression, okay? And that's all that is a polynomial. But if I set it equal to 0, and I say, now solve that equation, how do you do it? Well, you do it by factoring. That's why factoring is so critical, is because you have to use it to solve equations. I really don't have a good method. If I don't have a calculator, I don't have much method of solving that polynomial. I have no idea what x would be in order to make that equation be a proper equation. But they're the most fundamental rule of algebra. In fact, I think it's called the fundamental rule of algebra, is if you have two things multiplied together that are equal to 0, one of these things has to be 0. In other words, if A times B equals 0, then either A is equal to 0 or B is equal to 0, or both. But one of them has to be true. There's no two numbers you can come up with that multiply together that gives you 0, unless one of them is 0. Okay, you with me?
Yep.
Which means, and what we're looking at here is a polynomial where everything's being added or subtracted. In other words, I'm subtracting 7x, I'm adding 10. I could certainly move the 10 to the other side like this, but now I don't have any way of solving that. I could factor out the x, and I would have this. But having two numbers multiplied together that are equal to a number doesn't help me. I can't solve that equation that I'm looking at there. I can only solve it if it's equal to 0. Okay?
Okay.
So what you do here is, instead of moving that 10 to the other side, you factor the polynomial. Now factor that polynomial for me.
So it would be x and x, and then it would be plus and a plus.
Now, plus and a plus will produce the plus 10, but it won't produce a minus 7x in the middle.
Okay, so then two negatives.
Yes. As long as you know, by this plus, the only thing you know is that the signs have to be the same. They don't have to be plus. They just have to both be the same. And then you figure out what they are based on the middle term. And the middle term is negative, so both signs have to be negative. Okay, now what's the next step?
Factors of 10 that add to 7, so it'd be 5 and 2.
All right. Now, we've turned that quadratic into two linear binomials. You understand what a monomial, a binomial, and a trinomial is?
Yeah.
Polynomial just means there's many terms. So a polynomial could have 18 terms to it. That's all poly means, is many. Okay? And each of these terms is linear because the power in the x part is to the 1 power. That's what makes it linear. Okay? If I were to plot this would be two straight lines. But I don't really want to plot it. What I can now say is that x minus 5 has to be equal to 0, or x minus 2 has to be equal to 0. Solve both of those. First one gives you what? If x minus 5 equals 0, what does x have to equal?
5.
And if x minus 2 equals 0, what does x have to equal?
2.
So there's two solutions. Now the question is, are both of them valid? Because remember what this rule of algebra says. It says only one of them has to be 0. Doesn't say both of them have to be 0. It says one of them. So it's possible that one of these solutions we came up with may not actually work. Turns out that with most polynomials, both solutions work. But the moment I introduce radical signs or absolute value signs or logarithms or anything like that, very frequently you come up with two solutions and only one of them works. Now, how do I tell whether x equals 5 works or not?
Plug in 5 for x.
Okay, so I got 5 squared minus 7 times 5 plus 10 equals 0. Is that a true statement?
No.
Hold on. 5 squared is 25. Minus 7 times 5 is 35. Plus 10.
Oh, so it is true.
It is true. So x equals 5 is a solution. And like I said, with polynomials, usually both solutions you come up with are valid. So I would be very surprised if both of them were not true. Let's try the other one, 2. So I'm going to put in 2 here and 2 there. Is that true?
No.
2 squared is 4 minus 14 plus 10.
I don't know why I keep on doing that. Okay, yeah.
I'm not sure why either. What are you doing? Why are you? What is it that you're doing that's the mistake? Because I can't tell.
The first time when I did x squared, I didn't do it as 25, so then I did it as 10, and then it wouldn't be a true statement.
Correct.
But then this one, I think I was just
2x. Like, you didn't do x squared, you did 2x.
Yeah.
Ah, okay. Now, had you made that exact same mistake with the second solution, it would have actually worked out because 2x would have given you 4.
Yeah.
Unfortunately, I hate it when that's the correct. In other words, I hate it when you can make a mistake and get the right answer. You shouldn't have that happen in math. It's not a good thing because you tend to learn the wrong things from it. But so you're not multiplying it. It's not 2x. It's x squared. Okay.
Okay.
Now, that is this part right here, solving an equation by factoring. So let's do another one. Two ways to solve this. Both of them are equally correct. Both of them give you the same answer. What would be your inclination? How to solve this?
I think with the same method that we did before with the x's and in the parentheses.
Well, when I say there's two methods of solving this, one method would be factoring into two different factors. Does x squared minus 25 factor?
Yes.
To what?
To x minus 5 and then x plus 5.
Perfect. What two solutions does that give you?
Isn't it 5 and negative 5?
Yep. Now let's check both of those. Does this one work? Is 5 squared minus 25 equal to 0?
Yes.
Okay. Let's try the second one. Is minus 5, and always you got to use parentheses because you're substituting minus 5 for x. And if you don't use parentheses, you'll get the wrong answer. But if you use parentheses, is that a proper equation?
Yes.
Yeah, because minus 5 squared is positive 25. So 25 minus 25 is equal to 0. Now, I said there were two ways to do this. The way we just did it, probably the best, but probably not the way most people would do it, or it's not the fastest way to do it either. And it requires you know difference of perfect squares, right? In other words, you had to know difference of perfect squares to do it this way.
Yeah.
Let's do it a different way. I'm going to add 25 to both sides. Okay. See how I get that?
Mm-hmm.
Now, how would you solve for x if I was doing it this way?
Oh, right. This is the one. Okay. Gosh, I think you... Oh, you did a square root.
Perfect.
That's what it is.
I'm going to take the square root of that side and the square root of that side, which gives you x equals what?
Positive and negative 5.
That's the key. It's plus or minus. And the way you know, in other words, first of all, when I get down to this step here, if you are solving an equation by taking the square root of both sides, you always, always, always begin your answer with the words plus or minus. Because 95% of my algebra students will make this mistake. They will give you an answer of that. X equal 5. They will miss the minus 5. You understand?
Yep.
If I've solved it by doing difference of perfect squares, I can't make that mistake. Nobody makes that mistake if you solve it by difference of perfect squares. You're going to get both the plus and the minus answer. The only time you lose the minus answer is if you try to kind of do it the easy way. And there's nothing wrong with doing it the easy way. I'm a huge believer in the fastest way you can do math problems, the better off you are. But you got to be very careful. In other words, you have to put that plus or minus 5 in there. And you'll lose points for sure if you don't do it. No doubt about it. There's not a math teacher in Colorado that wouldn't take off points if they gave you the equation x squared equals 25 and you gave them the answer that x was equal to 5. You would lose points guaranteed. Alright, so we solved an equation by factoring. I think you kind of get that. Let's try one more. Let me think for a minute. There's an equation. Solve it by factoring.
Okay. I would say.
What's the first step? Always, what's the very first thing you always look for?
Oh, the greatest.
Exactly. Is there a greatest common factor? Besides the fact that we're looking at a cubic and you don't know how to solve cubics, that's a giant red flag that there must be something you have to do first.
Yeah, I don't think there's a common factor.
There's nothing I can divide every term by that gives me an even an answer but x.
Oh, X? Oh, geez. Every single time I do that, because I'm like, well, other than 1, so.
That's okay.
Yeah.
You just have to get used to considering the variable. In other words, you've always been looking at the numbers only. And you're right. There's no greatest common factor number that comes out of that. But you have to consider both the numbers and the variables. And what's left over? After I factor out the x, what do I get?
It would be.
Now remember what you do. You take every single term and you divide it by x. That's what's left over.
So it would be 2.
Not 2. What's that? What's x cubed divided by x?
X squared.
There's a huge difference between 2x and x squared. Okay? Now divide 7x squared by x. What do you get?
Plus 7.
X.
X.
Right? In other words, when I divide that by x, I don't lose both x's. I just lose one x. In other words, x squared divided by x is x.
Okay.
Okay, and then finally the third term, what do you get?
Plus 10x.
Okay. Now notice what we've done. We've turned it into a linear factor, x, times a quadratic, and we know how to factor that. How did we factor that before?
Wait, I have a question.
Uh-huh.
So with the 10,
Uh-huh.
you just put 10 there. Why wouldn't it be 10x?
Because I'm dividing that term by x. And in this case, the x divided by the x cancels out totally.
Okay, so because the other two were like
You
to the power of something.
subtract exponents. When I divide x cubed by x, there's really an exponent of 1 right there. So that's x squared. As all I do is subtract exponents. When I divide 7x squared by x, still that 1 there, subtracting exponents, so I get 7x. And when I divide 10x by x, that's a 1, that's a 1, I get 10, and I could say x to the 0, but anything to the 0 power is 1, so I really end up with just 10. And anything divided by itself is 1. That's an important concept. If I'm dividing x by x, then it's 1. It doesn't matter what x is. So I can cross those out and replace it with a 1. So that's how I got 10.
Okay, got it.
Okay? Now, we just factored this, a little alteration of it. So how would you factor what's that quadratic?
X and X.
Okay.
And then plus and a plus, and then 5 and 2.
Good. Now, this fundamental rule of algebra doesn't just apply to 2 things being multiplied together. If I've got 5 things being multiplied together that equals 0, one of those 5 things has to be 0. Okay?
Okay.
Huge concept. So whenever you're solving something like this, you set all 3 things equal to 0. So either, and people for some reason make this mistake a lot, they forget to set x equal to 0. X can certainly be 0 here. If x were 0, then the product of those 3 things would be 0. Or x equals minus 5, or x equals minus 2. So this has 3 answers, which you would expect. In other words, you usually have the same number of answers as the degree of the polynomial. And we're looking at a 3rd degree polynomial. Well, a 3rd degree polynomial is called a cubic, and it usually has 3 answers. Doesn't always have 3 because sometimes one answer can be in there multiple times. But the most answers it can have is 3. There's no way you're ever getting 4 answers out of a cubic. Just like a quadratic can produce at most 2 answers. And a linear function, if I go over here and I say x minus 7 equals 0, that's linear. There can only be 1 answer. There can't be 2 answers. That's it. X is equal to 7 and only 7. But the main point I'd like you to realize about this particular problem we just did is don't forget to set that equal to 0. That is, well, I didn't really mean that one. I meant that one. Okay? In other words, when I get down to this step, I have the product of 3 things equals 0. That's what I'm looking at. 3 things multiplied by each other equals 0. And you'll see that I could plug in all 3 of those answers and all of them work. Notice that when I plug in 0 for x, that's 0, that's 0, and that's 0. So x equals 0 is definitely one of the answers. And surprisingly, if you gave this as a test question, you get an awful lot of people that would only give you those 2 answers right there. For some reason, because that x is all by itself, sitting out there alone, people don't want to consider that that can be 0 also. It's not just x plus 5 that can be 0 or x plus 2 that can be 0. It's also x that can be 0. All right. That pretty much covers factoring polynomials completely. That pretty much means that you keep factoring it until you get it down to linear factors. Okay? In other words, what we had was a cubic, and we just kept factoring it. I was able to take a greatest common factor out of it, x, and then I was able to factor the quadratic into two linear terms, but I ended up with three linear factors. And that allowed me, I not only factored it completely, but I was able to solve the equation also. Remember, the key here is always we're attempting to solve equations. It's pretty rare when you have a real world problem where they give you an expression and they say factor it. That just doesn't happen in real world problems. But you do get real world problems where you, what if I did this? If I said x squared plus 7x is equal to minus 10. I could think of all kinds of real world problems where that's what you would end up with. Okay? How do I solve that? First step. This is not automatic. This is tougher than it looks. What would you think the first step would be?
Add 10x to each side?
Add 10, not 10x.
Oh, yeah, sorry. Add 10.
Okay. Now, the other answer was to factor out an x, right? Because
yeah.
If you look at it, in other words, usually your first step when you're factoring is greatest common factor. And I could do that. I could factor out an x like that. But now I got nowhere to go. I got two things multiplied together that are equal to a number. Well, I can't solve that. Nobody can. There's an infinite number of solutions to that. But, so the key is to recognize that we're not just looking at a normal problem, we're actually looking at a quadratic. In other words, if I do move the 10 over, then I have the kind of quadratic that I want 0 on the other side. In other words, when I've got 0 on one side, now is all I got to do is factor this. And I factored that many times, x plus 5 times x plus 2. As long as that's equal to 0, now I can solve it. And I come up with both solutions. So, part of the trick is to spot when you're looking at a quadratic and when you're not. In other words, the moment I look at this, I know I'm looking at a quadratic. And why? Well, a quadratic typically looks like this. ax squared plus bx plus c equals 0. That is the standard format for a quadratic. What does it have? It's got an x squared term, it's got an x term, and it's got a number. When you see all three, then almost always you've got to solve it by using the quadratic or by factoring it. Characteristics of quadratic functions. What's the number one characteristic of a quadratic function? There's really only one.
That they would have the squared and then...
That's it.
Exactly what you just told me.
No. I know what I just told you, and I was a little bit mistaken. This is a quadratic function also. It's just that I don't solve it by factoring. Or at least I don't solve it by what I called quadratic factor. In other words, I defined three things, but one of the terms I kind of made up. Okay? Every school teaches greatest common factor, and every school teaches difference of perfect squares, but I called the third one quadratic factoring, and this being where it has an x squared, it has an x, and it has a number. That's where you use quadratic factoring. Well, this example that I've written over here, x squared minus 5, doesn't have an x term. So I don't necessarily have to use quadratic factoring to factor it. In fact, if I move the 5 on the other side, I don't have to use quadratic factoring at all. Now I take the square root of both sides, and as long as I don't forget my plus or minus, there's my answer. Notice that I did not have to use quadratic factoring. But it's still a quadratic. In other words, the definition of a quadratic means there's an x squared term. Now, let's talk a little bit about definition of polynomials or not.
Sorry to interrupt you, but it's 7:30 already. So.
Okay, I will let you go. That is not a polynomial.
Okay.
Polynomials have to have whole numbers as their power. That's a polynomial. That's not. So the definition of polynomials is you have to have whole numbers as the exponents. That makes it a polynomial. If I have the square root of x equals 10, that's not a polynomial. Because square root of x is the same as x to the 1/2. All right?
All right.
Phoebe, I will talk to you on Friday.
Yep, sounds good.
Okay, bye-bye.
Bye.